Very quick warm-up problem, even though you guys already just did one. So just look at this example. I'm sure you guys will all get it. I want you guys to evaluate the integral from 1 to 3 of the function 3x squared dx. So very quickly, go ahead, do that problem. Okay. Okay, about 20 seconds here. All right. So if you integrated, you just would have gotten x cubed from 3 to 1. I don't need that plus c because it's defined. 3 cubed minus 1 cubed. I'm going to get 27 minus 1. Your final answer is 26. And again, Jennifer quickly reminded us on the last problem, what does this represent? Area under the curve. This is the area from where to where? From 1 to 3. Okay? So just reminding us, this is the area from x equals 1 to x equals 3 of the curve. Okay? And when I talk about the curve, guys, I mean this function, that 3x squared. I don't mean the x cubed function. Because when you graph it, we're graphing 3x squared. It's this curve, not the integrated curve. Does that make sense? Okay. So, here's what the fundamental theorem of calculus says. Here's what it is. And it's just restating it in different ways. Okay? So here it is. I have an integral from a to b of some function. We're going to mark it as a derivative, dx. And if I integrate this, I'm going to get uppercase f of b minus uppercase f of a. I think that notation looks, you guys are pretty comfortable with that. I don't think you have any questions on it, right?
Is it any different from the top one?
It's not any different. It's just how you choose to label it. Just understand that this is typically the derivative of that function, right? Okay. So, here's what I want you guys to understand is, let's say I was looking for like a particular value. Let's say I wanted to know what just f of b was alone, okay? I could rearrange this equation a little bit so that it made it. So here's what I'm talking about. Let's say I wanted to know what is f of b all by itself. Well, how would I get f of b by itself? What would I have to move? Yeah, I would take this f of a and add it to the other side, right? So that's exactly what's going to happen. If I wanted f of b, it would be equal to uppercase f of a, because I'd be adding it to the other side, plus a to b of f prime of x dx. Tonight's homework?
Yeah.
Well, yeah.
I tried.
Okay. Or, similarly, what if I wanted to solve for f of a? So this takes a little bit more thought. If I wanted to get f of a by itself, what would you move? You move f of b by subtracting it in this case, but there's a negative here, right? So what would you have to do to everything? Divide by -1. So f of a would really turn into a positive f of b minus a to b of the f prime x dx. This one's a little bit, the top one's easier to understand, but the bottom one is because I subtract and divide by a negative, which is why I get a positive, and then you're subtracting your integral. We good? Okay. So here's how we're going to use it, and this usually gets used with pictures, which is why you guys are seeing those pictures on your second and third pages, okay? So here's example 2 without the picture first. So let's look at example 2. We know that f prime of x is going to be equal to 3x squared. And again, I'm just changing the notation a little bit on you. But let's say f of 1 equals 5. I want to find f of 3. Okay? Now, let's kind of pick out some information that I know. Let's go here. What do you guys know?
Equation.
You know the equation, which is what? 3x squared. Do you know A or do you know B?
A.
Why do you say A? Why do you say this is A and not B? Okay, exactly. Because we have to realize that because the 1 is less than 3, this 1 value is our A value, which means they want us to find f of B, okay? So yeah, this is A, this is B. That's understood that that's my function, okay? So looking at this notation up here, which one do I want? Do I want the top one or the bottom one? I want the top one. So I want f of, and I'm just going to rewrite it, and we'll, f of B is equal to f of A plus the function A to B, f prime x, dx, okay? I'm just showing you that's the one we're using because that's the information I don't know. So now let's plug in everything. So I want f of 3 equals, well, what's f of A? What did they tell me? It's 5 plus my integral, my A value is 1, my B value is 3, my derivative function is 3x squared dx, right? Now, a lot of you guys look at this and I see some craziness happen where you guys try and integrate 5. You don't integrate 5. The only thing I'm integrating is 3x squared because that's the only thing that has the integral sign. This 5 remains the same. Okay? So this is just 5 plus, when I integrate 3x squared, we already did it once, we're going to get x cubed from 3 to 1. We don't need that c value. And again, we've already done this. What is x cubed from 1 to 3? Yeah. So we're going to get 5 plus 26, which is a value of 31. So that is what the function is at 3. Sorry, and I will move it down. Okay? You guys okay? Yeah? Maybe? Sort of? Okay. Alright, so let's try it with a different problem. Similar, but a little different. So example 3, and then we'll move on to the pictures. So, f prime of x is equal to 3x squared. Let's say f of 1 again is 5. I want to know what is, I should just put find, f of negative 2. Okay. Whoa. Whoa. It's coming. Give it a minute. Okay, there we go. So, ladies and gentlemen, I'm just simply using the same function. Okay. They've given me the function, the value, and they've given me what they want me to find. Okay? So let's just understand this. As I go to setup, what's my A value, what's my B value, what's my function that's going to go in the integral? A is negative 2. Why is it negative 2 this time? Okay, exactly. So we have to understand A is always our less value, right? This is going to be B. This case, they want me to find A. So I'm just going to rewrite this f of A, and this problem is going to be f of B minus the integral a to b of f prime x dx. So here's the way I like to look at it, guys. If they're giving me b and I'm going back to a, I always subtract. If they're giving me a and I'm going to b, I need to add. Okay? So you always have to constantly look. Are you starting at a function and you're going to the right on a number line, or are you starting at a certain value and going to the left? If we're going to the right, we add. If we're going to the left, we subtract. That'll make a little bit more sense when you see it on a graph. Okay? So again, they want to know what is f of negative 2, given that this is f of 1 minus negative 2 to 1 of the function 3x squared dx. F of 1 again was 5. I'm going to use this as x cubed from 1 to negative 2. This is f of negative 2. You guys all with me, or probably working ahead of me? So f of negative 2 is going to be 5 minus 1 minus negative 2 to the third. Be careful. So you have 5 minus, that's going to be 1 plus 8, so you're going to get 9. It's going to be negative 4. And guys, eventually, you will not need to write that first step. I'm just writing it so you know where I'm getting all my stuff from. Okay? I don't expect to see this on your homework. I could expect to see you guys skip to right here. Okay? All right. So, one thing I do need to tell you, on this graph that's below here, this is f prime of x. Okay? F prime of x. This is the graph of it. Okay? So, I'm also going to tell you that we know f of 0 equals 6. Okay? So, here's how we do this on a graph. What are they giving me? What x value are they giving me? They're giving me 0. You see the 0 here? Okay. So they're giving me 0. In this first problem, where do they want me to go? They want me to go to 2. Is 2 greater than or less than 0? It's greater than. So with that integral, what will I be doing? Should I be adding it or should I be subtracting it? So I'm starting at 0. I'm going to 2. I should be adding. So realize, here's what I'm starting with. My a value in this case is 0. So f of 0 plus, they say start with 0, go to 2 of f prime x dx. Okay? Now, you guys are going to look at me and you're going to be like, Ms. Seaman, they didn't give me the function, right? They didn't give you the f prime of x. They gave you a what instead? A graph. And if we're remembering, what does this really mean if I integrate from 0 to 2? It's the what? Area under the curve. So if I'm going from 0 to 2, and we're looking at this area right here, how much area is this from 0 to 2? This is 4. So we don't even have to do